This is actually working. Yeah, this is, hopefully this is working. Let's see. Oh, it is working. Very cool. So, today is a really simple one. I've got a new application I've been working on for real-time streaming of transit data. Here's a quick overview of it. We put in my Halloween intro music here. Takes a little while to get all the right sounds we like here. Okay, so what we're going to have here is Apache NiFi is getting us the data we want from a couple different REST endpoints. Some of these are from New Jersey Transit. This will give us bus, light rail, and rail, which is the major public transportation in my area. And then we're also going to bring in data from the Transcom Collective, which is a utility that connects New Jersey, New York, and Connecticut. Different transit updates, street delays, things going on out there, and we'll show that on a map. But first up, NiFi is going to get this raw data in JSON format, or from Transcom. All these are originally RSS, XML. We convert it into JSON in NiFi. I'll show you how easy that is. Then we push that data into my Pulsar cluster. For this demo, all parts of the Flippin stack running on one laptop. No Docker. Very simple standalone versions of each of the clusters, and we're going there. So we get into Pulsar. Once it's in Pulsar, I've got a Java function that's a Pulsar function that is going to do some enrichment, routing, transformation, adding a schema to each of these. So we normalize what the data looks like, do some data quality, data assurance, data validation. And then as a final bit, I have a little bit of machine learning using Apache OpenNLP that looks at these transit descriptions and pulls out locations, which is kind of cool. Could probably do some additional analytics on that. And then finally, to do some SQL analytics on transit. Transit is a new topic that I build from all those 4 different topics, just putting them to one standardized format so we get it all in one thing. And I'll add other ones from other countries and locations later, but that's a good start. And then we'll do some dashboarding with WebSockets, which can talk natively to Pulsar, even on our local cluster. And to describe the tables, I'll show it to you in Pulsar SQL, which is Presto Trino, just to give you a couple different looks here. So first up, I also happen to show weather data. So I'll show you how we do that. It's pretty easy. I'm just going to run this once. This is NiFi. This is both the runner and the display. So as you can see, this is pretty cool that it's all graphical, makes it easy. You can see I downloaded a giant zip file from the NOAA. It's a U.S. government agency that'll give you all the weather data for the United States. It's a big zip file. I unzip it, take out all these XML files, pick the sites only near airports. Those are the ones that are most interesting to me. I convert that to JSON, and then I'm sending that data down here to Pulsar like we do with everything else. And as you see here, I've got it paused right now. You can see the amount of data here that's locally cached. I'm going to start sending all this data to my local Pulsar cluster. So we're going to get some things running here, which is nice. Next up, I'm going to get an instance of the bus data. This doesn't get updated constantly, so I don't need it running all the time. But if I was doing a longer demo, maybe I'll leave that running. I can schedule runs in NiFi any way I want. See, I have it every 10 minutes. That's about when they're doing their cycle. So I get the data in from these 3 different endpoints for the different types of transit data. And in here, I'm just getting that from the REST endpoint, using NiFi to convert it into JSON, split those JSON files up, update a little bit based on the links, add some extra fields here. Could look at that real quick. I'm adding a company name. This lets me know where this is so I can add more generic data. I had a timestamp and then my favorite, a unique ID, so it's nice to have a key. I can also do send alerts locally at NiFi. Can maybe enable that in a different demo. I've done that in previous NiFi demos. I don't need to show that. This is for the whole flippin' SNI, not just NiFi. So we also have that Transcom data I was talking about. Again, this updates a little more frequently, but it's a lot of data. So I'm just going to run it on demand here, not constantly. Again, we get GeoRSS data, convert that into JSON, split that out into individual records, do some conversion here, and I could also do queries if I wanted to limit things out. I had a timestamp, unique ID, clean up one of the fields here so I could pull out lat and long easier. We're going to need that for the map. Then down here, I add a topic name on demand, which is nice. So any data comes in here, I could use this generically. And this just popped out number of records here, as we could take a look at the lineage of that as it's coming in. We could see this was New Jersey Transit data on the light rail. So that's fine. Pretty good. So we see some data coming in here. For Transcom, let's turn that on. As you can see, we've got 60,000 records backed up. So they're coming here. As we could see here, nice thing with Pulsar SQL, it's Presto, so it's got all those features of Presto. So you can see all the queries that you've run recently, how long they took, all that metadata. And I have a tool here that lets me query Presto. This is dbeaver, a nice open source tool for looking at that. And once I've connected to Pulsar, I can look at the data in the topic as if it's a regular table. Doesn't look any different. You look at the property data here. I get the fields, the type, and that metadata around there. Plus access to all these internal Pulsar fields. I could use them in my query. This is nice stuff, like when that message was published, what's that key I used, any metadata, who produced it. Those can come in for a number of queries. Pretty nice. And I could do that with other ones like the transit one, like the bus one, like the light rail, whatever you might have there, whatever data might be coming through. Just to quickly show you that. And one of the main functionality running is, we'll show you this in a minute. If we go to my code here, I've got that little dashboard running, and we've got the Flink running. But if I go to my local access here, I can access the status of a function. Now this function is taking all that raw data we saw in NiFi and is processing a whole lot of them. We had a little bit of crashing here because I'm trying to run maybe too much on this app, but we processed 1,292 records. We could see if we could process a little more here. And we're hitting this hard. I'm doing some NLP here. This might be a little too much to be running at once here, but we'll do it. You see, it's processing them as it gets to them. Maybe we'll tone that down for a little bit. I don't know if we need to see 30,000 records coming in all at once. So we've got that running. It's getting processed by a Java function I've deployed. I could have used Go or Python, and I do use those sometimes. So, it depends on what we want to run there. And the code is pretty easy. It's a standard function. And here I'm going to implement this. It comes in as raw bytes, which is the most generic format, easy to work with. And I do some debugging. And then I call my transit service. And I get my topic name if one was associated with this. I'm going to convert that data from bytes into something I can work with, and then convert it into an object. And then when I convert it to an object, I can send it to Pulsar as that specific topic, and it'll automatically create a schema based on that object. Set a couple of properties, bam, send the value. We're good to go. And these are to those clean versions of the records. And otherwise, I'm also going to send it to transit. Now for that Transcom data, I'm doing that NLP processing on that to add that location, and we add that to the metadata as well. And then all the records go to this other topic. So they don't just go to a clean topic, they also get routed into this giant topic of every kind of transit data, where I add the NLP based on that description. And again, we put it in, we should put that here. We could change this code on the fly. We'll have to deploy this again. You know, what are you going to do? Someone didn't look at this closely. So we got to look at, make sure we have that while that's running live. And then that's deployed. As you saw down here, it's running. I'll deploy this again. Maybe we'll show that in another one. It takes about a minute to deploy, depending on how many nodes in your cluster. And then a final thing I'm doing with this data before the dashboarding is I'm doing a simple Flink SQL. And if we could look, we've got 5,089 rows of this transit data. And these are the fields here. It tells me which of the services it came from. The description is the main code, the title it had, when it was published in their system, my timestamp, that unique ID I added, and that GUID is that location. So it looked at this description and found everything that it thinks is a location, and if there was any link associated with that. And as you can see, we can scroll back through a lot of data. And if I wasn't just using the Flink SQL client, I could put this in a deployed app and do things like insert it into another topic, insert it into other Flink syncs, not just Pulsar. It could be Kafka, it could be Kudu, it could be ScyllaDB, ton of different Flink syncs out there, and I could mix and match them based on the different catalogs I have. All that's documented in the code, which we'll look at. But let's keep this live. As you see, as new records get processed and put into this topic, they show up. Seems to be doing 2 at a time. Not bad for my little laptop. So we showed you all that running. We got the NiFi running. We showed you Presto. Let's show you something interesting. I'm going to show you that WebSocket table. As you saw, it loaded pretty fast. This is a standard Pulsar client. Makes a call over WebSockets to our cluster and get back data that I process with very simple JavaScript. As you can see, the values back to key, publish time, the title, and the deep description there, plus those NLP results we have there. And I could sort them. As you can see here, we've already got 32 pages of that. I also remember we were grabbing that weather data. I have that going here. As you see by the publish time, that's still getting processed. I'm running 7 concurrent live streams on this server, which is my laptop here, plus this broadcast. So NiFi, Pulsar, Flink, a standalone website here, plus dbeaver, plus IntelliJ, plus Chrome, plus OBS, plus a text editor. We might be doing too much, but we're going to do it anyway. Just because this is fun for me to do this demo. We'll see if I break my computer. And then I also have a map, thanks to the awesome people at Leaf.js, support Ukraine. And thanks to David, who said, hey, why don't you add a map? And I'm like, oh yeah. People might like maps. So all that data you saw, we had those Latin longs. Well, if I have a Latin long, it's very easy to do a map. And if I have a map with Leaflet.js, it's very easy to add, pop-ups, add this on a map. And I could scroll out. There's a lot of data points because I pushed maybe too much data here. As you see here, the redraw is going to be a little slow because I have probably at this point tens of thousands of items on this map. And you've got the option with Pulsar. I could just show what's happening since I started my client. So if you're just concerned and maybe you don't have enough memory for 10 million things, maybe you just show what's happening. I'm showing everything since the start of my cluster, and I've been running this for a couple days, so I've got hundreds of thousands of data points, which is fine in Flink. which loves to show tens of thousands of data points, as we saw 5,000 pages of them. But maybe a Chrome browser display is maybe too much. I might have knocked Chrome out there. Sorry, too much data for my map. Little easier to show it in a table, but I think I might have zapped out. No, we could still do it. Probably shouldn't run two concurrent live tables of streaming data at the same time while running all this other stuff. We'll learn in the future. Hopefully everything showed up and everything worked for you. Thanks for taking a look, and I'll see you